In this video we're going to take a look at the Hissss challenge on HackTheBox. It's an easy reversing challenge, and the description says, can you slither around the authentication? So as usual, let's download the file to our local directory and we'll go through some basic file checks. So let's start by making the file executable so we can run it, and we'll have a look at the file type as well. It's a 64-bit LSB Py executable. It's stripped, so we'll not be able to see function names and things like that, but it's a Linux binary anyway. Let's have a look at the strings as well, just see if there's anything interesting. We might see a password or something in here. We might get an idea what the program's doing, or we might just find part of a flag. In this case, there's quite a lot of strings. Let's try that again and do grep-i pass, see if there's any passwords. There isn't, but we see this mei pass, and it mentions a Py object as well, which is interesting. So let's try and run the program, see what we get. Run auth, and we get this error loading Python lib, and it's trying to load this libpython3 from our temp folder. Let's see if we got anything there. No such file or directory, okay. And we also have this glibc 2.32 not found. Let's have a look. LDD -- version. So we're running 2.31. This is looking for 2.32 libc. Okay. I did have a look whenever I was trying to solve this. I had a bit of a look around online trying to see if we could fix this error. But let's just go ahead and create a new project in Ghidra, and we're going to have a look at the decompiled code and disassembled code first of all. I'll just skip through this process a little bit because it's quite slow. And with Ghidra open, we have our program trees here, so we can see we have access to our global offset table and our data sections of the file and stuff like that, the binary. We have our symbol tree here, so we can go and have a look at the functions, we can have a look at what's being imported and exported, and we're going to want to go straight to our entry function here, unless there's a main method, and in this case we know that the program was stripped, so the function names and stuff were removed. You can see we have here function 00102, which isn't very easy to determine what it's doing. So we go straight to the entry function. We can see that this function is called. Let's try and open this up, and we can see this mei pass2 string again. We could go and have a look through some of these functions and try and determine what they're doing. What I did here was to search for strings, and if we go and have a look for the strings, what did we see as the error whenever we tried to run it? Let's try and run auth. We get this error loading Python, so let's try and put in here Python, and you can see here we've got this error loading Python, which is right here, and we can see it's being referenced at this function. So this is the error that we ran into, error loading this Python library, and we could go and have a look at that and see what that function was doing. We could go back and see where is this function referenced, so what point was this called. We have this unconditional call to that function, and we can kind of trace our way back through the program. We could also just go and have a look through some of these functions, but you'll quickly see that there's a lot there to deal with. Because we're seeing some mentions of Python, which is interesting in a Linux binary, and we keep seeing that string mei pass2. At this point I basically went online, did a bit of research to try and find out what some of these strings and what some of these libraries could be referring to. So let's go and have a look for mei pass2 and see what we get. So without even clicking on any of these links, we can see that PyInstaller is mentioned quite a bit, and we can see that mei pass is an environment variable. We could go and click on one of the links. Let's have a look at the Stack Overflow question, which was asked over 4 years ago, asking what does the mei pass stand for, and the answer is it comes from the PyInstaller's ancestor Macmillan Enterprise Installer. So at this point we could go and have a look for some previous write-ups. We could search like CTF mei pass2, and you can see we've got some write-ups here which are mentioning it. We could do the same and search for PyInstaller and maybe find some different write-ups. And while we're not likely to find something which gives us all the same steps, we might find a write-up which gives us an idea what sort of tools to look at, or some techniques that we could use to analyze files that have been compiled with this PyInstaller. In my case, let me just open up the link that I went to. This is a solution for a Crack Me challenge, and it also used PyInstaller. You can see the MEI pass string was used here, and you'll see that they use PyInstaller extractor to unpack and decompile the Python code. So if we go and take a look at this, so we can see on the description here it says this is a Python script to extract the contents of a PyInstaller generated Windows executable file. Now we're dealing with a Linux binary, so if we go and have a look at the GitHub here, it says the same thing, it's for Windows executable files, and it tells us that we can run this script and then it'll generate the compiled code that we can then go and decompile with a decompiler like uncompile6. So we need to get these PYC files. I actually didn't see initially the section down here which says pyinstxtractor can now natively extract Linux ELF binaries without other additional tools. So at the time of me solving this, I was googling around a little bit and I found pydecipher, which could also be used to do the same sort of thing. Let me just show how, as I went through it, and then we'll go and use the pyinstxtractor because that will also work. But we have this pydecipher which you can install with pip, I believe. So let me just do python-m pip install pydecipher, and let's try and run this and see if this works for us. Pydecipher, and we pass in auth. And you'll see here we get this artifact produce no additional output. We can try and run it with -v, and we get some errors here. So let me see, did that produce anything? And it didn't. So again, with a little more research online, I found that we can use 7z to extract auth. Let's try that. And what's that produce? We now have this pydata. Let's do file pydata. And it's zlib compressed data, and now we can try and run pydecipher on that instead. So we'll run pydecipher pydata, and hopefully this time it'll successfully grab everything. It looks like it did, although we have an error here with auth.py. But let's have a look at pydecipher output. We've got plenty of files in here. We could have a look and see what do we have that's pyc. So these are the Python byte compiled code, and one of them is the auth.py. Let's try and print it out. And because it's compiled, we can't see the original Python code, so it's not enough for us to work out what the password is, but we can see that this is the right file, and it will produce us the flag if we can work out what the correct password is. So now we want to try and actually decompile these files, but let me just go back first of all. I'm going to remove that folder, and I'm going to do it this time with the PyInstaller because we don't need to use pydecipher to do this. Let me remove the null and the py data, and let's go and try this with the pyinstxtractor. So this is just a simple Python script that we can go and download. Let's get the raw file wget, and let's run python pyinstxtractor and pass in auth. And we do that and it extracts everything fine. Let's go and have a look at it. Auth extracted, and again we've got our pyc files including the auth.pyc. So as we were told in the instructions here, once we have our pyc file, we should be able to use uncompile6 to decompile it. And we can see the GitHub for this here. Again, you can just use pip install to get this installed, and then we should just be able to run uncompile6 and pass in the pyc file, and that'll give us the original Python code. So let's actually try it. Uncompile6, and we'll pass in auth.pyc, and you'll see here it says requires Python 2.6 to 3.8. Now I have a lot of problems with Python installs. Let me see what we're running here. Python version. You can see I've got Python 3.92, so that's why this isn't working. And even if I install the Python 3.8, I'm not able to get this working. Let me actually just show Python install Python 3.8. If we happen to install this, I moved from Kali Linux myself to Para OS, and the reason I actually switched is because I was having so many problems with the Python installs, so I decided to switch over and start using virtual environments, which I have done. But unfortunately, let me just try and run here bin python 3.8 and -m pip install uncompile 6. So we get this error disutils.util. I tried copying these over from the Python 3.9 install to 3.8, which didn't work. I basically tried installing every Python 3.8 package out there. Whenever I try setting these up as virtual environments as well, I run into similar problems. So I actually spent probably about an hour trying to fix Python issues here and wasn't able to get this solved. So if anybody's got any tips on dealing with Python installs in Parrot, let me know, because I thought things would be a lot easier once I started using virtual environments, but virtual environments aren't much good if you're not able to actually install them. So if I do here virtualenv venv-p, and then we could try and say Python 3.8, or we could try and say bin Python 3.8. Again, I get these problems with disutils, but yeah, I eventually gave up on that. If anybody knows how to fix that, let me know. Another solution, another way that we can just decompile this code is to go to decompiler.com, and you can see here that it'll actually take PYC files, so we can go and choose file. Let's go and grab the auth.py, and it runs through that. We've got this auth.py file to download. Download file, you can see it's 0 bytes. Let me open that up. 0, okay, so there's nothing actually in that. Whenever I tried this, I got a slightly different result, but it still didn't have any code in it. So whenever I did this initially, I had extracted it with the pydecipher rather than pyinstxtractor, and whenever I uploaded that PYC file, I did have some comments in there, but not code. But either way, there's some problems with decompiling that, so let's see how we can solve the challenge without decompiling the Python file. So there'll be a few different tools to do this as well. Let's go and search for Python disassemble code. So we know that kind of like we have in Ghidra here, what we were trying to get is this original decompiled code, or well, even better than what we see here, because this is kind of a rough, this is not a great example, but you can see here this is a rough decompilation, so it's giving you kind of pseudocode. You can't just recompile this and get the same result or expect it to even compile. But and then we have on our left, we have the disassembled code. So if we're not able to get the decompiled code and get our original Python script, let's at least try and get something like this on the left so that we can manually go through and work out what's going on. And yeah, if we Google this, we'll see there's a couple of tools to do it. We've got this Python disassembler here. I used pydisasm, and if we pass in the auth.py, you'll see it runs through, and we've got our disassembled code here. So it's not particularly easy to read. It's not as nice as looking at a Python script, but hopefully it'll be enough for us to get the flag. So let's send this to a file, and I'll just call this disassembled, and let's open up disassembled and go and try and work through it. I do wish there was a bit of syntax highlight in here though. Let me have a look to see if there's any extensions which we can use to highlight this. Okay, let's try and install this and just see if it gives us a better look at this. I guess I'll need to rename the file actually. Let me close this down, and I'm going to move disassembled to dis.asm. I'm going to open dis.asm. Alright, that's looking a little bit better. I don't know whether I actually needed that extension, but there we go. So let's try and step through some of this code. I'll try and do it in as structured way as possible because whenever I was solving this, it seemed quite chaotic and my notes are a bit of a mess, but we'll see how it goes. I don't know too much about Python disassembly, but a lot of this seemed quite self-explanatory to me. So you have some constants at the beginning. We've got 29 constants, which seem to be local variables. So we've got decimals or strings, which are being stored. And then we have names as well, which has got 8 names here, which seem to be mapping to function names. You can see here exit and str, ord. And then we get into our code. So we have a block here which is import in sys. We have another which is going to load the input function, which is obviously going to ask us for this password, and then it's going to store whatever we provide, I guess, in the password variable. And next it's going to check the length of the password, so it's loading this length function, it's loading password, it's going to call the function length, and then it's going to load the value 12 and then do a comparison. So if the password is 12 characters long, then go to 46, which is going to be this line here. Otherwise, it looks like it's going to say, no, you've entered the wrong password. So providing we enter a password that's at least 12 characters long, we'll be able to jump down to this stage here, which is going to begin to do the checks on the password. And if we have a look at our first block, we can see it's loading the function ord, which will convert a character to a number. It's loading password and then load const 0, so it looks like it's loading the 0th element, so the first character of the password. It's going to convert it to a number, and then it's going to call this, you can see there was the binary subscript to basically take the 0th element, and it's going to call the function, and then it's going to load the constant value of 48 decimal, and it's going to compare whatever was retrieved here to 48, and if it doesn't match, it's going to go to 342, line 342, which is down here. Sorry, password is incorrect. So we need to make sure, let me go back to it, we need to make sure that whatever the first character of the password is, if it's converted to a decimal value, it's going to equal 48. So we could go to CyberChef or ASCII2hex.com or something, or you can do this in Python. I'm going to go to CyberChef and let's convert from decimal, and we'll convert 48, was it looking for, which gives us a 0. So we know that the first character of the password should be a 0. So what I'm going to do is, let's open up a new file here. I'm going to say let's do 0 is equal to, and then we'll pass in 0, and we'll basically be able to go through. We know that there's 12 characters, so we've got 12 right here. I know there's a far easier way to do that, but oh well. And we'll need to go through and map each one of these characters. So we've got the first one. Let's move on to the next character, and we can see that the next character, it's actually gone to load const 11, so it's loading the 12th character, and it's literally just comparing it to an exclamation mark. So we can go straight ahead and say, well, the last thing that we're going to have here is going to be an exclamation mark. And we get to the next character here then, which is loading the 7th element of the password, converting it to a decimal with this ord function, and it's also loading the 5th element of the password, converting it to a decimal as well, and then it's comparing them. So what that's telling us is that 5 and 7 are the same value, but it's not giving us any hint as to what that value could be. So we need to keep working through. I'm not sure what's the best way to solve this in terms of working through from character to character, or just working through in order of the program. What I did here was to go and say, well, we know that 5 is, let's just add a rule here and say equal to 7, and we can do the same thing for 7, map it to 5, and then once we find out what one of those is, we'll know that the other is the same. If we go down to the next part, then we have the load const 143, so it's loading the decimal 143, it's loading the 0th element or the first character of the password and converting it to a decimal. So we know that that was 48 in decimal, and it's going to do a subtraction here. So it's going to subtract 48 from 143, and then it's going to grab the 4th character of the password and then do a comparison. So essentially what we can see here is that if we subtract the 0th element of the password from 143, the answer will be the number 4. So we can, let's go and say we've got 143 minus 48, which is 95. So let's go and put in here 95, and you'll see that that's an underscore. So the 4th character is going to be an underscore. And then we can have a look at our rules and see, does that now allow us to solve either of these two? It doesn't, so we need to move on to the next part. So the next part here is going to load the first character of the password, which is actually the second one, and because it starts at 0, and it's going to load the third character as well. It's going to convert them both to decimals, and then it's going to XOR them, and then it's going to load the decimal value 30, and it'll compare it to that. So we know that the first character, i.e. the second character, XOR'd with the third character, i.e. the fourth character, is going to equal 30. And because XOR is a reversible function, it means if we have either of these two values, or if we have any two values, we can basically reverse this. So do we have 1 and 3? Let's go back and have a look. We actually don't have either of them, so we can't do anything with those yet. Let's we could add this as a rule, so we could say that the first character equals 3 XOR with 30. I should probably put something here like pass, just so we know what we're talking about. And we could do the same thing then with this here. We can say that this is equal to pass 1 XOR 30, and then we need to move on to the next part because we need to work out some more values before we can continue with that. And our next part of the function is dealing with the second and the third characters, so it's converting them to decimals, and then it's going to multiply them, and it's going to load the decimal value 5,610 and then see if that matches. So we know that well, if we can find the result of one of these, we can divide it by 5,610, and that will give us the answer to the other one. Do we have either 2 or 3? And we don't have them at the moment. So here we might want to say 510 divided by 5610 divided by, is it 2? Yep. Pass 2, and we'll say that that's equal. So we could do the same thing and say that this is equal to 510 divided by pass 3. But again, we need to work out what some more of the values are before we can continue. So we'll go down to the next one here. This one's actually just doing a straight up comparison, so we can see that the first character here is going to be P, so we can actually just go ahead and take this out now. This is a P, and probably what would have been a better idea to do here would be to go through and work out what are the easiest ones first. That's actually what I did, but it did make it a little bit difficult in that you kind of forgot which ones you'd already dealt with and which ones you hadn't looked at. So if you kind of go through them one by one, you can at least make sure you don't miss any values. But now that we have that P value, we can go and let's go and convert that. Let's do 2 decimal. We can just disable this part at the moment. We can have a look what P is. P is 112. So we'll go and add that there as well. And we know that then pass 1 XOR'd with 30 is going to be 3. So let's go ahead and XOR P XOR'd with the decimal value 30 is going to give us an N. So we can go back here and say that this is equal to N. And you might kind of guess here what the answer is going to be. So OP, a space, and then N. It looks like it's going to be open, right? And I did kind of just work that out myself before calculating this. But now that we have this part here, we can say that if we multiply N, which is, let me do the 2 decimal again. 110. Let's go ahead and do 110 times 5610 divided by 110, and we'll get 51. So the answer to that should be 51. Let's convert a from decimal 51, and we'll get 3. So that looks right. We've now got open. And are there any others then that needed 2? Doesn't look like it, so now we can move on to the next part. And here we can see it's loading the 6th character from the password and the 8th character. It's converting them to decimals. It's going to subtract the 8th from the 6th, and the answer should be minus 46. So 6 minus 8 equals minus 46. So we can reverse this and say that for 6 it is equal to minus 46, which was the answer to the equation, plus pass 8, and then we can do the same thing for pass 8, swap that round to a pass 6. But again, we need to go and work out some more answers before we can solve those. In the next function here we have the 6th character from the password and the 7th character from the password being converted into decimals, and then they're going to be XORed together and compared to this value of 64. So again, we can go back here and hang on, what were the numbers there? 6 and 7. So we've got another rule to put in here for 6, and we can say that it's equal to pass 7 XOR with 64. I'm not too sure why that suddenly gave me some nice syntax, but I like it. And then we can do the same for, oh, not for that one, for 7. So we'll do the same for 7, swap this round to 6, and again we still need to find out what one of these actually equals before we can go any further. The next part is grabbing the 10th character from the password and the 5th as well, converting them to decimals, adding them together, and then gets a result of 166. So that's 10 and 5 added together equals 166. We don't have either of them again, so we can say equal to 166 minus pass 5, and then we can say the same thing here, minus pass 10, but again we need to work out another character first. We have here the n, which is, okay, so it's loading the character n, and it's loading the 9th element of the password, which we don't have at the moment. It's going to subtract the 9th element from n, and then it's going to load a 1 and then do a comparison. So to clarify that, n minus the 9th character equals 1. So let's go and have a look here at, we can convert 2 decimal from n. That's going to give us 110. Let's try and change that to 109. Do from decimal, and we'll get m. So we know that the 9th character is equal to m. And do we have anything else we can work out now? It doesn't look like it. So we still need to find something else, but now we've got an additional character. Let's go and have a look at the next part. Now this is a part that took me a long time to solve, and basically the problem is with here, if you get one character wrong, it's going to mess up all the other characters that you get. So we can see here it's loading the 10th character of the password. What I didn't realize here, I thought it was loading the 3rd element of the password, but it's actually just converting 3 to a string. So this is just running str, so it's running something like str3, which is going to convert it to 3. So essentially that's just telling us that the 10th element of the password is a 3. Now that we know the answer to that, we can now go and start working out what is, we can now work out what 5 is. So we know that this 3 is equal to 166 minus pass 5. So if we reverse this equation and say what's 166 minus 3 in decimal, we'll get the answer to 5. So 3, if we convert it to a decimal, is 51. So we need to subtract 166 minus 51, and that gives us 115. So let's go and convert 115 to a character, and we get S. So we'll go and put in S into number 5. And now this is starting to come together because we know that 7 is also equal to 5, so we can just go ahead and put in a S here as well. You might have an idea what this is going to equal, but let's solve the rest of this anyway. So for example, we can see here that 6 is equal to 7 XORed with 64. So we now have this S here. I'm going to convert this to, in fact no, I'm going to disable all of that. We've got an S in here, so we're just going to XOR it with, what do we have XOR here? Yep, XOR it with 64, and that's going to give us a 3. So we can go ahead here and say this is a 3. And again, it's pretty obvious what this is going to equal, but let's have a look anyway. We've got this is equal to minus 46 plus past 6, and past 6 is a 3, which in decimal is 51. So if we do minus 46 plus 51, we'll get, well, we get 5, but actually that's not correct. So it's 46 plus past 6, which would give us 97. So if we convert 97 to a decimal, to a char, then we'll get A. So let's go and put in our final character, and now we've worked out that the flag is open sesame. And that's the challenge. I hope you've enjoyed this video. If you have any questions or comments, or you know how I can fix all my broken Python installs and virtual environments in Pirate OS, let me know in the comments.